you. Thank you so much, and welcome, Dan. And thank you for accepting our invitation. And the other ladies and the other team joining us tonight or this morning for Dan. Thank you so much for taking time and for joining in time as well. We are, of course, going to give it some time as people keep joining, but we're excited to have this conversation that is really timely, very important for every one of us in tech and business. I think this is very important for everyone. So yeah, I'm very excited for this conversation, and I hope you all are. Before we start, I'll introduce myself. My name is Femias Orishaba. I will be moderating this session and taking through any questions that come through or comments. And I'm looking forward to an interactive session with each one of you and even as others join us today. So please feel free, prepare your questions, prepare your comments. And if there is any confusion around anything, maybe you don't know what APIs are, you don't know what a target is, you don't know anything, it's okay. Please prepare your questions. So I will dive right in to introduce this platform and where you have come. Some of you might have seen the link somewhere online and decided, I think this is interesting, let me register. And maybe you're finding about us for the first time. And so I will introduce to you what WISIS, or Women in Cybersecurity, is, and explain to you why we are even having this conversation at this moment, right? So Women in Cybersecurity, or WISIS as we call it, is a group of ladies and gentlemen who are very passionate about cybersecurity as a field, and we have the mission to educate each other, retain each other, and have everyone at least recruited, and we keep growing our careers in cybersecurity and in tech as in general. So Uganda has an affiliate that is connected to the global WISIS, which is headquartered in the USA, and our president is right here on this call. She's called Diana, and you will meet the rest of the team along the way. So in WISIS, we are mostly about networking, mentorship, and growing each other. So if you join WISIS, which is very easy to join, of course, we shall talk about that later. You will have an opportunity to attend such sessions where we discuss matters regarding cybersecurity and technology. You'll have an opportunity to be mentored or to mentor someone. You will also have opportunities to take part in competitions like CTFs, or you will get some certifications or sponsorships, training, career growth. You could even become a public speaker depending on where your journey is going. So there is so much to gain from being a member of WISIS. And as you can see, this is one of the very many events that we are holding, and we're excited to have these sessions. Yeah, so I hope that helps you to understand where you are at the moment. Yeah. So it's 5 minutes after 7 p.m. East African time, and I'm guessing for Dan it's very early in the morning, like 8 a.m.
It's actually 9 a.m., so not so bad.
9 a.m. Okay, not so bad. So yeah, we are not going to take more time. I'm going to introduce our speaker of the day and give it up to him to take us through whatever he has prepared to take us through. So Dan Barahona is a co-founder at AppSecu University, which is championing the education of over 13 1,000 people about API security and application security in general. He is passionate about building automated competitive intelligence. And of course, he's also helping very many organizations stay ahead of the competition, giving different insights in intelligence there. He has an experience of over 25 years in cybersecurity. So we are in the presence of royalty when it comes to cybersecurity.
No.
And yeah, so he has held so many executive roles in different organizations, including Qualys, HP, Anomaly, and of course, championing AppSecu University, where all of us are very lucky to have attended different programs. I will share with you my experience with AppSecu University after he has presented. Yeah, so maybe from technology, he's also very passionate about pediatric cancer advocacy. I've seen a lot of his work collecting money to champion research regarding cancer among children. And so I think he's doing a great work in that field as well. So we're excited, Dan, to learn from you, to share with you, and for you to also discover a community that we have in East Africa. And thank you so much once again for accepting our invite. So yeah, over to you.
Oh, wonderful. That was
Take it
probably
away.
the nicest introduction that I've ever had. So
Oh,
thank you. Thank you so much for that. Let me try to present my screen. And if someone can let me know if that's coming through okay.
yes, we can
Thank
see
you.
us. Perfect.
Thank you, Agnes. Very good. All right. Well, listen, I'm really honored to be here. Maybe one day I can do this kind of a session in person in Uganda. I would love that. And I had the honor to meet Diana at RSA recently, which was a real thrill. But let's go ahead and dive right into today's topic. Why APIs are every attacker's favorite target. Just a little bit more to share with you following that lovely introduction. So yeah, I am one of the creators of AppSecu University. And actually, it's not 13,000 students; it's 130,000 students that have enrolled, and we invite you, everyone, to join and participate. All of the courses that we have on our website are completely free. We don't charge for them. We are not in the business of education. We don't need to make money from this. We have another business, but we created this site about 4 years ago, just recognizing that there was a real gap in knowledge, expertise, training on the risks and the best practices around APIs. And we just started making these courses and putting them up for people to consume. And it just really hit a nerve. People love the courses, the material, the instructors. And as you mentioned, we do a lot of other things. We have a Discord channel with over 15,000 members. So it's a great place to learn and participate. It's a great way to build your own profile and become visible in the community. We've got AppSecCon, where it's a hosted virtual conference we run 3 times a year. If any of you would like to speak at AppSecCon, we always love to have members from our community. And we have a lot of cool tools, Open Vault Bank, which I'll show you, and Bolt and other tools to help you be successful in your cybersecurity endeavors. The thing that makes all of this possible is the other side of what we do, which is also called AppSec, but it's over on appsec.ai. This is the business that we run, and it's basically focused on helping organizations automate and test their APIs regularly to find vulnerabilities. So that's a little bit of the background, but let's get into today's topic, right? And the talk is broken into 3 acts, if you will. The first act is, why do we care, right? Why do attackers love APIs? The second act, I'm going to go into a lot of real world examples, and we're going to incorporate the OWASP top 10 into those examples. And then the third act, what are some best practices? How can you keep your applications secure? Now, just in case you don't know what APIs are, it stands for Application Programming Interface. It's basically how websites and machines and servers communicate with each other, right? So when you log into your bank, there's an API call from your device to the bank, all right, to authenticate you. If you want to transfer money, if you want to deposit a check, that's all powered by these APIs. So they're really amazing. It's a really amazing sort of integration path that really makes the internet work, right? Almost everything that you do on the internet is via an API call. But there are some other things that you can also do with APIs. For example, you can look up Lady Gaga's cell phone through an API on the Oscars website, and I'll show you how that worked. You could find Max Verstappen's passport on the Formula One website. I'll show you how that happened. And you can even sell Bitcoin that you don't even own. And let me show you how that actually happened. This was really quite remarkable. It was a few years ago, and there was a hacker, a pen tester who wanted to poke around on the Coinbase website, and they did what hackers do, right? They created an account, they deposited some money, they started trading using all the features of the service, and watched all the traffic from their browser to the Coinbase website. And what you see on this page is what the traffic looks like when you do a trade. In yellow, you can see the parameters of the trade, right? Hopefully you can see my mouse moving, but you have the base size is the quantity. Oops. You have the limit price is the price, product ID, Ethereum in euros. That's the asset that they are selling, and their account information down below. This was a completely legitimate request. What hackers and attackers like to do is send intentionally erroneous requests in order to see what kind of error messages your server might return, because sometimes those error messages are revealing. So he took this request, which was perfectly valid, and in order to make it an invalid request, he backspaced over the product ID where it says Ethereum, and he wrote Bitcoin. He owned Ethereum, did not own Bitcoin. And he went and hit submit, and he waited for the error message to come back. But he did not get an error message. What he got back was a trade confirmation. And he must have been absolutely stunned, but his $1,000 of Ethereum became $43,000 of Bitcoin. And it sold his Ethereum as Bitcoin, and it deposited this money into his account. As I say, he must have been absolutely shocked, and probably thought he was going to prison. Instead, he went on to Twitter and explained that he had discovered this potentially market nuking vulnerability, and could someone please get him in touch with the CEO of Coinbase. Coinbase actually gets a lot of credit. They immediately reacted. The CEO himself responded. They shut down the market for 24 hours. You could not trade on Coinbase because of this issue. And a week later, they explained what happened, right? They actually blogged this. You can go look it up. And they reported that the underlying cause of the bug was a missing logic validation check on their brokerage API. And what that all means is simply their application, their backend was checking the base size, the limit price, the source account, the target account, but it was not confirming the product ID. It just assumed whatever product ID was in the request was the product that the user owned. Which actually is a fair assumption to make if the request had come from the UI. In the UI, there's no way to do this. There's no button to sell your Ethereum as Bitcoin. Of course not, right? But at the UI or at the API layer, you can really do anything you want. And if the backend doesn't know better, it will process it like it did here, right? And that's what we would call a logic flaw. right? It's not an injection or cross-site scripting. This is a logic flaw in the application. And that is the kind of thing that attackers love to find, right? They're very, very difficult to detect, very difficult to defend against. And if you find one of these flaws, you can immediately exploit them, as they did here. And I get a lot of questions like, whatever happened to this person? Did they go to jail? No, they did not. They actually got rewarded with the largest bug bounty ever paid out by Coinbase, $250,000 paid to this person who discovered that that attack. So that's hopefully gets your attention on what kind of things can happen with your APIs. So let's step back a little bit. Why do attackers love APIs? Well, first of all, they are everywhere, right? 83% of the internet is powered by API calls. It's probably even higher than that. Gartner has declared that APIs are the #1 attack vector. Certainly the most successful. Nokia ran a survey, and only 4% of organizations are comprehensively and continuously testing their APIs to look for security flaws. And so this is a great situation for attackers, right? APIs are everywhere. They're not well defended, and they're vulnerable to these kinds of things. So that's #1. They're everywhere. #2, APIs have direct access. So if you think about like the classic, Tom Cruise Mission Impossible type of attack, it's very complicated, right? You have to do your reconnaissance and then infiltrate and get somebody to click on the link and then escalate your privileges and then move laterally and all of these complicated steps. This is what sort of the classic cyber attack looks like. With APIs, it's so much easier, right? As you've already seen in the case of Coinbase, right? You poke around, you try things out, you find a vulnerability, you exploit the vulnerability. That's it, right? There's nothing more to the process. So APIs are very convenient, right? If you can find a flaw, you can exploit a flaw, right? They are also very easy to find. There is a myth that organizations have that APIs are this infrastructure, this plumbing that sits behind anything visible that the user can see, and therefore we don't really have to worry about them so much. Attackers exploit that myth every day, right? Because actually that's totally false. They're not hidden. They're very, very easy to find. All you need to do is use the inspect feature on Chrome or any browser, go to the dev tools, and the APIs are right there. Anyone can see them. I'm showing you here an example from United Airlines, but every website works this way, right? They didn't do anything wrong. This is just how the internet works. So APIs are very easy to find. And what exactly are attackers exploiting? Well, what they are not exploiting is old-fashioned vulnerabilities, right? You hear a lot in school, I'm sure, SQL injection, cross-site scripting, buffer overflow, CVEs, common vulnerabilities, right? That is not what is causing these breaches, okay? Those are pretty low-hanging fruit, and your firewalls will defend them and so forth. What they are exploiting are things like BOLA, broken object level authorization, RBAC, mass assignment, and logic flaws, right? These are more complex. These are more nuanced, right? They rely on exploiting the functionality of your app, not the infrastructure of your app, right? And the reason why is the stuff on the left is easy to defend, right? Nobody gets breached through an injection, right? Our firewalls will block them, our gateways, our code analyzers, but the stuff on the right is almost impossible to detect. And I'll explain to you why later on in the talk. Okay. Let me just pause for a sec. I know I talk a lot. I talk kind of fast. So first of all, make sure you can still hear me. My internet hasn't broken. Can I get like a thumbs up or something from folks to let me know this is
Yes,
all right?
we can
All
hear
right.
you.
Very good. Thank you. All right. So let me describe to you how virtually every API attack happens. You've already seen it at Coinbase. So here, simple schematic, you got the front end, talks to an API to the back end, okay? And I draw this yellow box around the front end, okay? That's because we put a lot of security in the UI. We authenticate users there. We run web scanning on the front end. We control what data you can see in the front end, what buttons you have access to. It's a very locked down environment, right? But what attackers do is they'll use your UI, they'll create an account, they'll use all the features and watch the traffic and discover all those APIs that are sitting right behind it. And then the next thing they do is they just bypass your UI, right? And all of those controls that exist in the front end no longer apply when you target the API directly, right? And if you think about the front end, it's a very structured, controlled environment, right? I can only do what you let me do. Right? I can only see the data that you show me. I can only press the buttons that are visible to me. But at the API layer, it's completely uncontrolled. And what I mean by that is it's just a command line interface. So I can write any request I want and send it, just like that guy did to sell the Bitcoin. And if the backend doesn't know better, it will process that request, right? And so what attackers are looking for at the API layer, and what they often find, number one, over permissioned APIs, right? We have APIs that have too much power, too much access, too much permission, and that's what they're looking for, right? They return too much data. They have access to functions that you don't want users using. They expose logic flaws that cannot be exploited in the UI, right? This is why fundamentally attackers love APIs. Okay, so hopefully that's all coming through. So let's go to Act 2, which is what's happening in the real world. I'm going to give you a bunch of examples, and I'm going to teach you about the OWASP API top 10, right? And in fact, the OWASP top 10 looks like this, right? I'm sure you've heard of OWASP, the Open Worldwide Application Security Project. It's a nonprofit, and they publish a number of top 10s, a really outstanding body. I strongly recommend checking them out. They probably have chapters in your region as well. I used to do this talk where I would go through the top 10 line by line, and like everybody went to sleep. Honestly, it was so boring. So what I like to do now is talk about real examples, right? So thank you for liking my jokes, by the way. That's very yay. All right. So I spent a weekend a few years ago looking up API breaches. And frankly, I ran out of room on the slide. There are so many examples of organizations getting breached through their APIs, right? And what stands out to me from this slide is, and this, by the way, just the public ones, right? Who knows about all the non-public ones? But what stood out to me was not just the volume of breaches, but the types of organizations. These aren't like little credit union banks and small tech companies and hospital clinics. These are great big tech savvy companies, right? Coinbase and Instagram and McDonald's and Duolingo and you name it. These are the kinds of companies that are getting breached, right? And they have all the best technology, right? Web app firewalls and code analyzers and detection tools and, well-paid, security people and all of that. And they still got breached, right? So something about these attacks are getting through those defenses, right? So that's what we wanted to figure out. So what I'm going to do for the next about 20 minutes is I'm going to take a few examples and I'm going to map those breaches to this top 10. Okay, so let's start with McDonald's. Okay, so this is a vulnerability discovered by Ian Carroll, who's a very well-known, pen tester, hacker and so forth. Does really fantastic work. You should check out the stuff that he publishes. So Ian went to McDonald's job site. It's called makehire.com. And on it, as you can see here, there's like a chat bot where it sort of interviews you and has a conversation. And behind the scenes, it creates a job application for you, right? And the way it does is it sends an API request to put at /API/lead/CEM/XHR. Okay. And it assigns you a lead ID, which is kind of like a applicant ID. And in this case, his lead ID was 64,185,742. Okay. Remember that 742. So like a good hacker, the next thing he did was get rid of the UI, bypass the UI, and start querying the API directly. And this is what it looks like, right? He probably opened up Postman or some other terminal, and he sent a request to look up his applicant ID or his lead ID. But actually, he didn't look up his lead ID, which ended in 742. He tried someone else's, like in this case, 740. And of course, you should not be able to look up someone else's lead or job application. And so he expected to see the error message, but he didn't get an error message. What he got back was all of that user's information, right? You can see their name, their email address, their home address, all of the information that that person submitted as part of this job application, right? And think about that. There are at least 64 million other records in here that all they have to do is just, increment through all of the combinations and start collecting all that information. And that is the biggest issue that we see with APIs. It's OWASP number 1. You'll hear it called BOLA, Broken Object Level Authorization. And it's basically, can user A access user B's data? That's the fundamental premise of this. It can be more complex than that, right? But at the end of the day, it's a permission, a data level permission problem, right? What data can the user access? If this had been properly designed, they should only have access to their records ending in 742. If you try someone else's, you get a denial, right? But in this case, at the API layer, you could put any value in there. It's actually quite an easily guessed parameter. It's just an incrementing integer. They could have made that, more complex. And this is number 1 on the OWASP top 10. All right. Let's go to the next one, which my example here is Duolingo. So as you can see here, they exposed 2.5 million records. I'm a Duolingo user. My kids are Duolingo users. So when I learned about this breach, I went and I tried it out myself, right? So the way it happened was there was another hacker. They poked around on Duolingo and they saw all these API calls. First of all, the APIs had no security, meaning you could call them without authenticating, no username, no password, no credentials. And one of these API endpoints accepted an input of an email address. So if I send an email to this endpoint, it would reply back to me and tell me, is this an existing Duolingo user? And if so, everything about them. So I tried it on myself, and this is literally what happened. I took a screenshot as soon as it happened because I couldn't believe my eyes. I didn't even have to go to a terminal or anything like that. I just went to this browser, to that URL, and I put my email address. This is my real email address. And in a half a second, with no challenge, no credentials, no authentication, it returned all this data about me, right? What languages I'm learning, my streak, all of this other stuff, right? And of course, I could have put my email address or my kid's email address or Diana's email or Michael Jordan, anybody's email, and it would have returned their data just the same. And so that is OWASP number 2. It's actually OWASP number 1 also, right? I shouldn't be able to access other users' records, but in this case, it's also OWASP 2, broken authentication. In this case, it wasn't weak or poor authentication. It was no authentication. Literally, the door is wide open. Anyone who can find this API can use this API, right? And you would be shocked how many examples, and you'll see more, of no authentication APIs. Breaches through APIs with the door wide open, right? So you've got to make sure, and the only reason this happens is that myth that APIs are hidden and no one can find them. And as you can see, that is clearly flawed. Anybody can go find them and exploit them. All right, 1 second. The next example I'm going to give you is from Venmo. I don't know if you have Venmo. It's a payment platform. It's kind of social. So if I want to pay my barber or house cleaner or whatever, I can use Venmo to send them money. And as I said, it's sort of social. So on the Venmo homepage, they had a feature that would show the last 10, 20 transactions in real time, but it was anonymized. So it might have my first name, no last name, things like that. Well, as you can see here, this attacker discovered it, saw it was a public API, and no authorization needed. So wide open door, right? Anybody can query this API. But here's the key. When the attacker queried the API directly, right, not through the UI, but just called the API from the terminal, it did not return anonymized data. It returned the entire record, right? First name, last name, transaction details, you name it. It was all in there. And so they realized this was leaking basically all of their information. This was a malicious person, and they went and harvested 200 million transactions out of Venmo in complete detail, right? And so what's the lesson here? Well, they created a generic API, the developers, that basically you could query the backend and it would return the entire transaction. And then they relied on the UI to filter out only the stuff that they wanted to show the public, right? They should have created a special API for this homepage that only returned the minimal amount of information required, right? And that is what OWASP 3 is about, broken object property level authorization, which is frankly a really complicated name. What we're really talking about here is excess data exposure. We have an API returning way too much information, right? They don't need to, that API did not need to return last name and transaction details and account information. It just needed to return first name and dollar amount or whatever it might have been. That's called excess data exposure. There's actually a second half of OWASP 3, which I'll describe here, which brings us back to Formula One, right? So it turns out if you want to be a Formula One driver, you actually have to have an account on formula1s.com in their driver portal. And so these guys, this case, it was Gal Nagley and Sam Curry, who are two other legends in the space. They found this portal for logging in and creating your driver account. And so they created an account for themselves. And as you can see here, they created an account for Sam W. Curry at Gmail. There's his first name, there's his last name. But then they went one step further. And when they sent this request, as you can see here, they did a put request to /API/users. And I guess 12934 is their user account, their user ID. But they added this extra bit in blue here in this box. They just guessed, frankly, and they just sent it to see if it would work. And they put in role ID is 1 and name is admin. And they're basically trying to give themselves admin rights. And this is a pretty standard or common way to do that. And they tried it and it worked. And they suddenly had admin rights on formula1.com. And within a few minutes, they were looking at Max Verstappen's passport information, at which point they knew they truly did have admin rights. They closed their laptops and fired an email off to formula1.com, informing them of this data leakage, and Formula One promptly corrected it. But that is what we call mass assignment, right? The ability to modify records or to escalate permissions by sending a properly formed API request, right? In this case, they were able to take their public account and elevate it to admin just by sending this request. They should never have had the ability to query that endpoint at all, right? Or much less be able to modify their records. So that's OWASP 3. Next example I want to give you is from Trello. And I imagine a lot of you have heard of Trello or used Trello. It's collaboration platform. So if I want to invite you to my Trello board, there's a feature for that, right? I give Trello your email address, and some backend process sends you an invitation. And that backend process is accessible via API. That API was also public and also unsecured, meaning anybody could query it with no credentials. All you got to do is send an email address to that endpoint, and it would reply to you and say, is this a Trello user, and all this detail about that user. So when this attacker discovered that, they're like, all I got to do is just guess at emails and then start harvesting their data. So they went onto the dark web and they collected 500 million email addresses from other breaches, past breaches, and they sent 500 million requests at this Trello endpoint looking for matches, and they got 15 million matches. And what you see on the screen here is them putting all that data up for sale on the dark web, right? They're saying, out of these 15 million unique lines, it contains emails, usernames, full names, other account information, all because Trello had published this API publicly with no credentials that returned all this data. Okay, that is OWASP 4, unrestricted resource consumption. And basically, whenever we see, brute forcing and millions of records, that's what this is. Okay, and you may be thinking to yourself, how did they not notice 500 million requests? Like, don't they have rate limiting? Don't they have anti-bot? Do they have, some sort of detection tools to look for this kind of abuse? And the answer is actually yes, they had all of that. And still, this attacker was able to execute this attack. And the reason why is all of those defenses, they're basically just speed bumps, right? They don't block you, they slow you down, right? And an attacker has all the time in the world, right? If you slow them down, doesn't mean they can't do it, it just takes longer, right? So what did Trello do? Well, they actually published this a little bit later, and they said, look, because of the misuse, we made a change so unauthenticated users can't query data on other users. And all that just means is they took this open, unlocked door, and they locked it. And now you can no longer query it without credentials, without passwords. You have to have a valid account. And that was effective because it's a lot easier to detect abuse from authenticated users than anonymous users, right? An authenticated user, like if Dan tries to invite 10,000 people to his Trello board, you're going to notice that, right? That's an anomalous behavior. But spreading 500 million requests over a year's worth of traffic and using 10,000 different IP addresses, that is very hard to detect. So that's OWASP 4. I'm going to give you two more examples, and then we'll move along. This one is from a dating app called Bumble, and frankly, they got a lot of things wrong. They had unsecured endpoints. They had BOLA, so user A could access user B's data. They had excess data exposure. But what makes this OWASP 5, which is broken function level authorization, is they didn't just expose data that belonged to other users. They exposed functions that an end user should not be able to execute, right? And in this case, Bumble, they have a classic freemium model. So they have a free tier and a paid tier, or premium. And so there's an API where you can look up what account type you have, right? So that would look like a GET request to something like /API/account type, right? That's fine. If I want to look up what kind of account I have, totally fine. But they also exposed put and post on that endpoint, which means not only could I look it up, I could also change it. And so simply by executing a request to this endpoint, I could take my free account and give me premium access. And by the way, I could do that for any user for that matter, right? And that is a function I should never have had access to. If I try to do that, it should say, denied, you have insufficient permissions. Only the backend can do that, right? So we have to protect data authorization, but we also have to manage function authorization. And then the last one I want to give you, to me, it's one of the most important, I think. It's from Instagram, and important because it really gets back to this concept of business logic. So what happened here was, if you wanted to take over a high profile person's Instagram account, let's say you wanted to take over Taylor Swift's Instagram account, here's how you could do it. You would go to Instagram, you would pretend to be Taylor Swift, and you would say, I forgot my password. And Instagram would send a 6-digit code to the real Taylor Swift, which you would not get, right? But it turns out there's an API where you can submit your guess, right? So all I got to do, 6-digit code, that's 1 million combinations. I just start at 0 and just keep incrementing until I get to the right code, and then I take over her account. Well, naturally, they had some protections, right? The first protection was a 10-minute timeout. So if I didn't get to the right code within 10 minutes, I'm out of luck. But frankly, 10 minutes with an API on a site like Instagram, you can easily go through 1 million combinations, no question. Protection number 2 was after 200 guesses, it would not let you send any more guesses, right? And so I think this hacker probably thought they were finished, they were done, but they tried one last thing, which was they changed their IP address. And suddenly they got 200 new guesses. And they realized all they had to do was just keep changing their IP over and over and over, making 200 guesses each time, probably run it all in parallel. All you need is 5,000 IPs, something you can easily script, and you could get through all 1 million combinations within 10 minutes and take over anybody's account that you like, right? That is OWASP number 6, unrestricted access to sensitive business flows, right? In this case, the sensitive business flow was the password reset logic, right? And so the takeaway here is, as developers, as product owners, we tend to think like, does the app work the way it's designed? And in this case, it actually was perfect, right? From a functionality perspective, if I forgot my password, I could go request a reset, I'd get my code, and I'm back up and running. Perfect. It's exactly how we designed it. But the way they implemented that feature actually created its own exploit, its own vulnerability, right? So I really like doing these talks to engineering teams, developers, because we need them to think not only how is the app meant to work, but also how is it meant not to work, right? And in this case, there were a lot of things they could have done differently. Number 1, IP address is completely irrelevant. There's no reason I should get 200 guesses for each IP. Doesn't make any sense. It's illogical. Number 2, 200 guesses is way too many, right? No real human is going to try 200 times to type in their code. After 2 or 3 failed attempts, you're going to type that code really, really carefully. And after that, the code should expire. It's no longer valid. You get 3 chances and then that's it. It's done. You have to get a brand new code. And the third thing is stay away from incremental IDs, right? We actually saw this with McDonald's, right? If you use integer IDs, you make it incredibly easy for attackers to guess, right? In this case, just iterate through all possible combinations till you get the right one. Or in McDonald's, just keep changing the user ID and then get someone else's information, right? So stay away from incremental IDs. Use UUIDs and other more complex things that make it harder for attackers. So that's 6. This is what the rest of the OWASP top 10 looks like. In the interest of time, I'm going to skip this. We actually have, excuse me, we have a course on AppSecu all about the OWASP top 10. And so if you want to learn all about it in detail, please come and enroll for that. All right, so let's go to our last act here. Was there a question, Emma?
No, but no, Dan, it's okay. You can continue. Sorry, you are muted.
Sorry, I have to unmute myself. Okay, can you hear me all right?
Yes, you can.
All right, thank you. So let's go into the last section here. How can we secure our APIs? So to help us answer that question, we went back to this list and we analyzed every one of these and many more, and we tried to identify what was the attack pattern, what was the breach, what was the vector that succeeded here. And we categorized all of these breaches and we added it all up. And this is what the data looks like. Right away, two things jump out. Number one, the top 4 dominate how APIs get breached in the real world, right? And right at the very top is, and it's almost 70% of the breaches, is unrestricted resource consumption, right? And you might look at this and say, all right, the best thing we can do to improve our security is tighten our rate limiting and our bot defenses and all of these kinds of things. And excuse me, I actually think that's the wrong conclusion, right? What I take away from this is those defenses are not perfect. They're not comprehensive, right? We saw it at Trello. We saw it at McDonald's. We saw it at Venmo, right, where there was this brute force attack, right? And what this says is, when your API is revealing or leaking data, attackers will get very, very creative and very clever at finding ways around your defenses, right? They will take months. They will, if your rate limiter says only 1,000 requests a minute, they will do 999, right? They will abide by your rules, but they will just fly under the radar. They will use thousands of different IPs. They will use residential proxies. They will find ways to defeat your defenses, right? So what I take away from this is you should have rate limiting. You should have bot detection. You should have all of these things, but don't think that they are perfect, right? Because if your API is leaking data, they will find ways around those defenses. And ultimately, this isn't the root cause. This is just saying your defense is not adequate. It's not the root cause. If Trello wasn't leaking data, they wouldn't have sent 500 million requests, right? They would have said, nothing interesting here. Let's keep looking somewhere else, right? So it's not the root cause anyways. It turns out, this was very eye-opening, the root cause of 90% of the breaches on that last slide were these 3 items, or a combination. It was 1, 2, or 3, okay? And there's a reason why I like giving this talk to developers is I say, listen, if you don't remember anything from today except this, it's that the main, you can improve your security by or defend against 90% of breaches simply by addressing OWASP 1, 2, and 3. And what are we talking about? OWASP 1 is authorization. Can user A access user B's data? That is a logic. There's probably one line of code in your application logic, and you can protect against that. OWASP 2, broken authentication. APIs with the door left wide open. It sounds ridiculous, but you saw how many breaches happened because of that. Don't assume your APIs are hidden, undiscoverable, and you don't need to secure them. Just lock the door. And then number 3 is data exposure, right? If that Venmo API was only returning first name and dollar amount, there'd be nothing interesting there, right? But because it returned first name, last name, account details, all of that, that makes it interesting to attackers. And that is excess data exposure, right? So this is what I call the big 3, OWASP 1, 2, and 3. If you can defend or build those protections into your app logic, right, you've just prevented 90% of the breaches out there, okay? So let's just talk, as we kind of wrap up here, about what are the techniques, what are the options available to protect our APIs, right? And there's really 2 options. There's monitoring and there's testing, right? Monitoring is basically video camera, right? Like watch the traffic, look for weird things, block it, when it happens, and alert and so forth. And the most common monitor out there is the WAF, the web app firewall. basically watches the traffic, and it allows things, it blocks other things. But here's why the WAF missed all of those attacks. Every one of those attacks, they had a WAF in place, and it failed to block. And here's why. The fundamental reason is these attacks don't look like attacks, right? Remember when I showed you that, like what's exploited, what's not exploited? WAFs are great at blocking SQL injection, cross-site scripting, and stuff like that, okay? But let's make this real. Let me show you an example. Here is a request that is clearly bad, right? It's a GET request for user ID equals nothing or 1 equals 1, okay? This is the most basic SQL injection that there is. 1 equals 1 will be true. We have an OR statement, so now the whole statement is true. And if you're vulnerable to this, this is going to collect your entire user database, right? Nobody gets breached this way, right? Because your WAF will see this and it will immediately know this is malicious, right? This is an injection. They're attempting to bypass controls, and it's going to block it 100% of the time, okay? Now, how about this? Here is a request from user 10 to delete transfer 1, 2, 3. So when this request gets received at the WAF or at the gateway, just one sec, the first thing it does is it inspects the request. So let's inspect this. User 10, let's assume user 10 has username, password, properly authenticated. So that's a check. It's going to look at the endpoint. In this case, it's called transfer. Is that a valid endpoint? Yes, another check. It's going to look at the payload, right? The 1, 2, 3. This endpoint expects an integer, not a string, not a binary. It wants to see a 3-digit integer. Check. That's a perfectly well-formed parameter. And then it's going to look at delete. And it's going to say, is the method valid for this endpoint? That's also a check. So when this request lands at the gateway, at the firewall, it's going to pass all of the checks and it's going to let it through. But imagine now that transfer 1, 2, 3 doesn't belong to user 10, belongs to user 11. Suddenly, this seemingly, good request is completely malicious and fraudulent and should not, under any circumstances, be allowed. But your firewall doesn't know that, right? It doesn't know if transfer 1, 2, 3 belongs to user 10 or 11 or anyone. It doesn't know that. It's just inspecting the sort of the language, the formulation of the request, not the properness of the request, if you will. And this is the fundamental reason why detection is so difficult for these types of attacks. Okay, so that's the challenge of monitoring. Let's now pivot to testing, right? And of course, if we can test our apps, we can find these flaws, we can correct them, but testing has its own challenge. The main challenge here is the sheer breadth of scenarios that you would need to test for. And I break it down into these 3 buckets: security, data, and logic. Frankly, security is the bottom. It's the lowest, right? Sounds kind of silly, but this is the easy stuff. Do we have unsecured endpoints, right? The door open. Are we using incremental IDs like McDonald's was doing? Are we vulnerable to basic injections and cross-site scripting? Are we not doing our input validation? That's security. Then you add on top of that data level testing. So what kind of data is my app accessing? What kind of data does it return? Is it sensitive? Is it too much? Is it well controlled, right? And then the hardest is logic, right? These are your personal 0 days, if you will, right? These are never going to show up on a CVE report or something like that. And some examples: object ID manipulation. So selling Bitcoin that I don't own, right? Cross-account access. Let me look up my next door neighbor's Duolingo records, right? Or function abuse, elevating my free account to paid on Bumble, or giving myself admin rights on Formula1.com, right? These are function level abuses. And then you take all of this breadth and multiply it by hundreds of APIs across my organization. Engineering, making continuous releases, right? I got to keep up with all those changes and wanting to automate this and find these flaws that might exist before they ever make it into production, right? This is the testing challenge here. So, what are the approaches that organizations make or take to test their APIs? Well, there's really three that I see out there in the real world. Option one, unfortunately, is do nothing. Remember that 4% at the beginning? This is actually more common than you might believe. And people do nothing because it's frankly very, very hard to do this. Option two is quite common. Do it yourself. So this would be like a red team or a pen testing team or something like that. And they will use tools like Postman and Burp and Zap. You might be familiar with some of these. These are amazing tools. They're very, very powerful, but they're also very, very complex, right? If you've ever installed Burp, there's got to be 100 different buttons on it, right? And so you've got to really understand the technology, but you've also got to know all the attack vectors and how to simulate them. And that just means you better have a ton of time on your hands. And option three is you pay someone else to do it. Classic annual pen test. You hire a firm and you say, hey, come in, I'll give you a week, maybe 2 weeks, hack everything in sight and give me a report, right? And there's no way you can do a comprehensive job there. They give you a report and then you say, thank you very much, come back in a year, right? None of these are very good solutions, frankly. So I mentioned at the beginning that's, we're in the business of doing this. And what I want to show you is a tool that you can use. It's totally free. You could go use it today. And I'm going to share a new window here. So Diana, I was going to do a little bit of live demo here and show you a tool that you all can use right away. So can someone just confirm that you can see this
Yes.
fake bank? All right, thank you. So check this out. This is actually quite fun, I think, because I like stuff like this. So two things right away. One is I built this site and you can use it. It's called openvaultbank.com. It's a totally fake bank. There's a lot of silly, funny things in here. But what's cool about it is that it actually it's loaded with vulnerabilities, and you can learn right on this website. So if you come to the Learn page, it will actually give you all the information you need to start hacking on this site. I'm going to go ahead and reset the demo data because sometimes people hack on it too much and it needs just like a little bit of house cleaning. So the other thing that's cool about it is we give you the cheat sheet. So if you don't really know what you're doing and you just kind of want to build your skills, this will literally tell you how to go hack it. There are 12 vulnerabilities. That's actually a lie. There are more. There's some hidden ones that we put in there as well. But there's BOLA in here. There's mass assignment, data exposure, all of those kinds of things that that we talk about, right? And it will even tell you how to find it. Well, first, log in as Alice. Go to the accounts page. So so this is the target, if you will. Now the tool, we built this thing called AppSecu Bolt, right? And if you want to try it out, it's just a browser extension. You just go AppSecu Bolt, and you will see it here on the Chrome store. It's also on Firefox. So just Google it, you'll find it. And you can install it. And if any of you have ever used, actually used like Burp before, it's kind of like a lightweight Burp that just sits inside your browser, right? So you don't have to install anything. You don't have to proxy traffic or filter data or anything like that. So let me show you how to hack this bank with a tool that you can take advantage of right now for free. So I'm going to go ahead and start capture. Okay. And I'll just refresh my page. And you can see, all right, it saw the request to collect the home page. Okay, that's not very interesting. Let's go ahead and sign in. So I'm going to log in as Alice. Alice123 and sign in. Okay. And right away, you can see this request, post to auth token. This is basically me logging in, right? And I can see all of the details of that request. There's the actual request body. And here's my token, right? So I could actually take this token and tamper with it or do other things. All right. So that's kind of interesting. And you can see this tool is just simply listening to the traffic and finding the endpoints as they show up. Right. So let's go ahead and maybe let's go visit the savings, area. Let's go to checking. I have to fix, looks like there's a bug here, invalid date. I'll have to take a look at that. But let's go ahead and so you can see here, right? These are the requests to get that data, right? And you can see the response. This account, this checking account has an ID 2001. The owner's ID is 1001. Okay. So now let's go do something even more interesting. So I want to go do a transfer. Let's say I want to transfer from savings to checkings, and I want to send $1,000. I'm going to go ahead and review that, and I'm going to confirm the transfer. Great. You see this API V1 payments. That's the transfer, right? And here's the request, right? From account 2002 to 2001 in the amount of 1,000. Okay. This is fine, right? Alice owns both of those accounts. But here's where it gets kind of more interesting. You see this like hacker icon, we call it manipulator. So I can take that request and I can start to tamper with it. This is what the request looks like in sort of raw format, which is a little bit ugly. I'm going to go back to form and I'm going to go to the body parameters. This is where I see the parameters of that request. So the from account, to account, and the amount. So let's try to do a transfer for some other, let's try 2006. And we'll send that. And that did not work. Okay, we got a 404, and it says that account does not exist. Okay, let's try 2005. Okay, we got a 201 success, and it worked. So we just stole $1,000 from whoever is the poor owner of account 2005, right? This is what pen testers do. This is what hackers do. This is what, that guy at Coinbase basically did, right? They're listening to the traffic and they're modifying those parameters to see if it works. In the case of Coinbase, there would have been a parameter for product ID, and he simply backspaced over that and he wrote Bitcoin instead of Ethereum, right? So that's what this tool does. And so, the idea is to help you discover APIs. It'll find the parameters. So this API's got 11 different body parameters. I personally tend to look for things that look like incremental IDs, right? Those are pretty easy to tamper with. It will show you all of the endpoints, and it will even produce an Open API spec. If you're not familiar with Open API, it's basically how we document APIs, right? This is what machines use to understand and read APIs, and this tool will literally create that documentation for you. This is really important. If any of you go into pen testing or red teaming or things like that, this is invaluable for you, right? So, Diana, just wanted to give a little tour there of a tool that you all can use. It's, as I said, it's totally free. Anybody can use it, and hopefully will give you a way to learn as well with that Open Vault Bank. So, and thanks folks for sharing some of those links in the chat. Let me just finish here, share my screen one more time. There we go. I just want to put up a thank you page here. Appreciate you inviting me and listening to me. If you want copies of slides, or we also issue CPE certification. So if you've got to collect some hours, you can fill out that form. but yeah, that's my talk here. Hopefully that gave you a good introduction to APIs, why attackers love them, and maybe even some inspiration to come to AppSecu and learn some more. So with that, I'll catch my breath a little bit and happy to stick around for questions.
Wow, very well presented. I don't know how to call it. I don't want to even say it's a class. I don't want to say it's a master class. I think it's extraordinary that you're able to summarize all these amazing concepts in such a short time, giving live examples of companies we have related to. We use, someone I said Masterclass Pro. I guess it's a Masterclass Pro Max.
Oh, you are too kind.
Yes. Thank you so much for delivering such an amazing presentation, keeping us engaged. Given that it's a bit technical and out of some people's comfort, managing to keep all of us engaged in the session is really, really amazing work. So kudos to you. Thank you so much for that presentation. And I think my biggest takeaways are that tools are good, but there is more to it, and we have to pay attention to logic, flaws, and the way we build what we build, apart from, the design. And also you mentioned that designing functionality with security in mind, that is very key, I noted. And you also seem to think it's very important to train developers to think like security engineers. Yeah, so thank you so much for that presentation. I would like to open it up to the audience for some questions. I will check in the chat if there are any, but if you have a question, please feel free to put up your hand. Yes, we have hands coming up.
Very good.
We have Otim Wendo has his hand up. So over to you, Otim. Then we shall have Angela and then Zahara. Thank you.
All right. Thank you so much, Dan. This was just a bullet or throwing salt at an open wound. So it was good. Yeah. I think for me, during the presentation, you put up a slide that was very interesting, and I was willing to dive into it. That was the API, AI and MCP. I don't know if you were going that direction, but you literally threw some barbecue sauce to my appetite, when you went that direction. But I think, yeah, so if you are going that direction, please call me back. And the team at large here will be back. I just wanted to say that. I have no questions. The meal was on point. I'm going home for a good nap. Thank you.
Well, I did kind of skip that, so you are very observant. We have a whole other workshop just on MCP and AI. The thing I will say is a lot of people are very focused on AI coding and MCP and what does it mean for security. It has a lot of implications for security, but what I like to point out is it's not like we don't use APIs anymore. That AI stuff and MCPs is just another consumer of the APIs, right? So when I use an MCP to, for example, let's say I install an MCP for Jira. What that means is from Claude or ChatGPT, I could say, hey, check if there are any new Jira tickets. And Claude will use the MCP to connect to Jira. Well, it's still going to create an API call to query Jira. Jira does not suddenly speak natural language, right? It still requires an API call. So all of these AI tools, they're just another interface to the API, right? Jira still needs an API request to do anything. And so we're not in a post API world. We're actually in a hyper API world, because now we have agents and bots and AI tools that are querying, they're integrating with our tools through those APIs. And so I was at a banking conference recently, and they were talking a lot about this and recognizing that we used to have two consumers of APIs: people, right? Me clicking on buttons, or machines that we, tightly integrate to use our APIs. Now we have agents that are using our APIs, and we have to be aware who or what is consuming our API, and then have appropriate policies around what they can do. For example, I personally cannot send 10,000 PIN code requests, but an MCP can, right? And so it helps to understand where your API consumer is coming from, what is it, and then have the right policies and controls in place. So Otim, thank you for noting that, and maybe we can come back in a future session and do the full MCP talk.
You have my
Wow.
time.
Thank you, Wendo, for raising that and for getting us a promise from Dan that he will be back.
Oh, very good.
Yeah, hopefully soon we shall host him again, and he will definitely dive deep into other concepts. So our next question is from Angela Babazi.
Yes, thank you. Thank you, Dan, for your presentation. I unfortunately or fortunately do not work in the cybersecurity space. I work in the product management, product ownership space for a health tech product. And it has grown to the point of where we now need integration. So APIs are coming in a lot. And my question is, mine is not a question really. It's a query about the tool. If I do start using it, is patient data safe?
Very good question. That's a very good question. So the tool that I showed you is 100% private. And what I mean by that is it's local. It's running inside your browser. It's not transmitting any data back to any server or anything like that. So you can use it, right? You don't have to worry that the site, if you're testing your own company's products, that it is going to be sharing any data back to our servers. I will say that our tool has the option to integrate with our company products, right? But that is off, right? You have to opt into that. And if you so choose to, then you get access to more automation, more attack simulation, more sort of attack knowledge that our sort of, flagship product does. But the tool that I showed you in the way that I showed it to you is completely private. It's all running completely locally on your browser, and nothing gets shared unless you choose to, sort of activate the more advanced mode, if you will.
Thank you, Dan. I can testify. I actually contributed to the beta testing of the AppSecu Bolt, which I really enjoyed. I think it's a good tool. And I've also seen it in other presentations somewhere. So thank you, Angela. Question.
Thank you.
Yes. Our next question is to Zahara. Yes, you can unmute. Yes.
Hello, can you hear me?
Yes, we can hear you now.
Hi, Dan. Thank you so much for the presentation. I think I have around 3 questions. One was about the public exposure of our APIs on API board. I actually actively use it.
Oh, wow.
Yeah, I use it, and I wanted to ask if the commercial future of it is also safe for companies to use it. I think you've clarified that. I don't know if that applies to the commercial part of it as well. Then the other question I had, or the challenge I faced with it, was on service APIs that don't have a UI to interact. So how do you intercept that communication there? Then the second one was about downloading the post-money corrections from the files from the board. I think I remember I had a conversation with you around that on email, but the communication got lost somewhere. But I remember I shared with you the correction. You asked me to share with you the Postman correction, and I see why it was failing to be exported to my Postman tool.
Oh, okay.
Yes. Yeah, so if you can help us and maybe explain more on how you can resolve those. Thank you.
So thank you, Zahara, for that and for using the tool. I love that. It's getting out there into people's hands. So yeah, I think we addressed the first question. As I said, Bolt is completely private, local. If you want to use the more advanced features that our sort of company product does, it is a cloud-based service. So there is, your data has to come over so that our engine knows how to analyze your APIs and build the attack simulations. But even then, your data is your data. But that's a separate, conversation. On exporting to Postman, you will see at the bottom of Bolt there are two buttons. One says OAS and one says JSON. So OAS is just simply Open API Specification. So it will take all of the traffic that it has discovered, the endpoints, the parameters, and it will generate the OAS, or it's often called Swagger file. That's one flavor of API documentation. As you pointed out, another standard is the Postman collection. We actually don't have a Postman collection button. Makes me think that maybe we should add one. That could be a really cool thing to do. So thank you for planting that idea. And as you mentioned, you're on some of our sessions. You contributed in the beta earlier as well. We really listen to that stuff. Like a lot of features in the product have come from the community, right? So we're really grateful for that. But if I wanted to create a Postman collection like today with what it does, I would probably export the JSON. That will basically spit out all of the raw data that has been detected and harvested. And then I would probably throw it into like Claude or something and say, here's JSON I've collected from, monitoring my browser traffic. Can you please manipulate this into a Postman collection? I bet that would work. I bet it would do a fine job. And but I do like the idea of adding that button. So, maybe next week you'll see a new feature.
Next week. Wow. That is so quick.
That's
but
how
we appreciate
how we roll over here, We don't like to sit around. As you've seen with Bolt, like I personally am the guy who codes it, believe it or not, and I hear about a cool feature, I want it in there today if I can. So that's how we roll.
Interesting. Thank you, Zahara, for that suggestion. I know we have we are enjoying the conversation. I'm not sure if there are any other questions, but I believe very many people here are probably energized and excited to go back to their organizations. And you usually talk about documentation and zombie APIs and shadow APIs, and we probably don't know what we are protecting.
Yeah.
I would like you to talk more about that. It's not very technical, but I believe people maybe in management and in different positions or technical side, while we discuss with our developers, how do we bring up that conversation and what documented, how can we actually tackle that part of documenting and inventory? Actually, I think it's part of the last issues. You probably didn't get into it, but you could talk more about it.
Right. Yeah, I did miss that. So thanks for bringing that up. It's probably the number one question that we get, which is, how do we find all of our APIs, right? We don't know if we know them all, how do we find them? And The honest answer is it's not easy, right? And there is no like, just do this and you'll get a perfect view of everything. It's really a multi-approach process. If you want to find all your APIs, it's typically going to involve things like Bolt, right? Like you just go and, sort of manually discover. There's traffic monitoring. So if you have a web app firewall, like an F5, Cloudflare, things like that, they can detect APIs. They have products, they have features. It's watching all the traffic, right? So they've added intelligence into their products that will identify APIs in the traffic themselves. So that's a really good way. Your firewall probably already does it, and you can just go and enable that feature. On third way would be code scanning. So we actually have a product called Code Bolt, which is a way to crawl through GitHub and GitLab and other repos and find APIs and API calls in the code itself, including calls to third-party APIs. So that's the third way. There are others. There's crawling and fuzzing and dictionaries and stuff like that. But one of the best ways that I think kind of gets overlooked, and it's frankly because it's so low tech, is actually just go talk to engineering. It might sound kind of silly, but I met with the guys over at Kroger, which is our largest supermarket chain here in the US. They've got literally thousands of supermarkets. They're very high tech. They did a presentation once. They shared they process over 1 billion API calls a month through their e-commerce and things like that. So their API platform team, they needed to go find all the APIs, and they basically walked around the engineering teams and just like interviewed, methodically, like, what are all the APIs you have? And then they did something very creative, I thought, which was they created an API marketplace inside of their organization, and then they motivated the developers to publish their creations, their APIs, into the marketplace, right? Because routinely they would find some group that needed an API would go develop one when one already existed, and they weren't even aware of that, right? So it was a way to publish and share and document the APIs that they are running, right? So back to your question or comment, it is a big problem. It still is a big problem. There's not an easy answer to it, but those are some of the ways that that you can go about getting a better handle, whether it's monitoring traffic through the firewall or scanning the code. Those are probably your two best bets for discovering APIs in a semi-automated way.
Wow. Thank you so much for commiserating with us. First of all, we have the same problems.
Yeah.
We're all trying to find solutions, but you've mentioned quite insightful options there. And guys, this session gives CPE points. If you go on and fill the link, I think you will be able to get a badge for attending this workshop. I know you've taken off time, and this is highly exciting. I can see people in the chat, and I wish everyone could get a chance to speak, but unfortunately time might not allow for that. But thank you so much, Dan. And I was charged with a chance to testify about the program and AppSecu University. I have tagged the link within the chat for AppSecu University. If you haven't been to the university, please go ahead, click on the link. All the programs there are free. I just recently completed a program with Session by Confidence in collaboration with AppSecu University. I think Zahara was also in the group.
Wow.
Zahara, am I right? I think Zahara was also in that program.
Yeah, Zombe was in the first cohort. Yeah.
Okay. So we completed that program, and it was amazing. For those that have not had the chance, it is connecting with AppSecu University. So you have to complete almost all the programs on the university page. They're all free. You get a badge for each, but the challenge is actually you have to go in and study that work. And it's both good for even if you're technical or not, if you're really getting into this whole business of APIs, that's a very good place to start. I would like to say the program was very rigorous and very interesting. Dan and his colleague created a Happy Hacker, a lab that you have to go in. It's almost like what he has showed us as well. There is a vulnerable environment where you can discover all these 10 issues and be able to become good at hacking APIs actually. So slowly by slowly, you can build that knowledge. And if you have your team, you can actually team up and do it as a challenge and work on it as if a CTF. There are badges for each course, like I've said. And even if you just want the fundamentals of what Dan has just spoken about, like everything is right there in detail with video content, and it's really self-paced. So you don't have to worry that it's going to lock you out. Also, they have certifications. Those ones are for paying, not for free. But I know ladies here who have done those certifications. Some are still preparing to do them. I am preparing to do one of them. So there is so much to learn from AppSecu University. Please go ahead and check it out, sign up, create an account, and just start learning. We know that in tech, you just have to keep learning, right? Yeah, so I think I've spoken enough. I have already introduced WISIS. For those that were not here, this platform is Women in Cybersecurity. We are an affiliate in Uganda, and we bring together ladies and men and allies who are pushing ladies in cybersecurity and in tech, and we are supporting each other to learn, to network, to mentor each other, and to grow. So I'm going to invite Diana, our president. She will definitely talk about the rest of the team and talk about the rest of this session. Thank you. Over to you, Diana.
Thank you, Femius. I normally use the word that when I delegate, I don't only delegate tasks, I also delegate authority. So this evening was all about you and, you know, taking us on, but thanks for guiding us through that and for sharing your testimony. Dan, I can't say much, but to say we are very, very grateful for you making the time. And I was blessed to meet you physically. And yeah, there's a lot of, I think, the ladies that are more close around me that have had some experience with AppSec, and I thought I would, introduce it to the bigger group of women in cybersecurity, but also the gentlemen that you have seen on the call. We will hold you to the promise around diving into AI and MCP.
Very good.
Yeah, but really, really, we are grateful for the conversation. It was quite engaging. I was happy to see people ask questions here and there. So I believe you have planted, a good seed that is actually going to get out of the soil and grow, and we have more skill sets around how to secure our APIs. So thank you so much. And for everyone that made time to attend and join us this evening, I hope that your time has been well spent, and see you on our next webinar.
Thank you so much. I really appreciate it. Take care, everybody.
Take care.
Thank you so much.
Have a good night, everybody.
All right. Bye-bye.
Bye.